For task 1, we used the values from our data frame to plot a graph showing a positive linear correlation.
We defined a parametric function r cos t r sin t 0 for task 2 for the range 0 less than t less than 1000 to plot the ellipses.
For tasks 3 and 4, we used Manim's built-in function moveAlongPath along with the orbit paths from task 2 to display the planets moving around the Sun. We scaled each inner planet's number of orbits by Earth's orbital period and each outer planet by Jupiter's orbital period so that Earth and Jupiter took 1 second per orbit each. We also modified task 4's parametric function slightly to r cos t cos theta, r sin t, r cos t sin theta to incorporate the inclination angle theta for each planet.
After separately defining the integrand, the integral loop, and the orbit time function in task 5, we first calculated the time array from an angle lin space, and then used the numpy interpolate function to set time as the independent variable in each set of axes.
In task 6, we ran a lin space through each function to get the start and end point of each line in the spiral graph. We used our function to return an array of line objects, which could then be plotted between the orbits.
Finally, for task 7, we simply saved the position of each planet relative to the center in an array and interpolated a sample of 5,000 points to form these curves. As an extension, we created a simulation of the solar system in the Unity game engine and allows players to create custom solar system configurations stored in the browser through binary serialization. We currently have 2 modes: Sandbox, where you can create custom planets and edit orbital parameters, and Explore, which allows you to fly around and land on planets. All of the orbits are calculated using methods developed in previous tasks.
We also wrote up a paper with some interesting maths we derived, such as formulae for calculating orbital parameters from the instantaneous velocity and position vectors of an orbiting body. We came up with a method for deriving the ellipses in two-body systems, and finally explored some non-elliptical orbits as well.
Finally, we created a website using the front-end framework Vue.js with Tailwind CSS, where we displayed the task animations and code snippets. We also embedded the Unity project by building as a WebGL app.
All of our extensions can be found in the description below.